Well, we have to break it down to binary. So what I've done at the bottom of the screen is I've taken each of the three IP addresses, the client, the server, and the router, and I've broken their IP addresses down into binary. Then I've taken the subnet mask and I've put its binary equivalent as well. The issue here is that everywhere that there are ones in the subnet mask, that's now the network ID. That means that the ones and zeros in the IP address must match in all three cases for that section, that section of all ones. Now, back when we just had 255.255.255.0, that would be the green section was all 255s or all ones. They all matched. But now that we moved the bar over, we moved it 5 digits to the right, we added those 5 more ones to the network ID, you'll notice that the client IP address, that network ID no longer matches the network ID of the server and the router. So we have a problem. So how can we fix it? Well, what we can do with a subnet mask of 255.255.255.248, each network gets broken into a block of 6 host addresses. Now, why do we say 6? Looks like there's 8 listed here, right? Right? We go ahead and start with the network ID that we had, 110000010101. Basically, that's 192.168.10. And then when we now have the subnet portion of the network ID, we'll just start with all zeros. And then we use the 8 different combinations that are left from the remaining 3 bits for the host ID. Right? We have 000, 001, 010, 011, 100, 101, 110, and 111. And then what we have to do is eliminate the top and the bottom. Why do we do that? Because you can't have all zeros or all ones in the host ID. There you get your remaining 6 host addresses. So the network ID would be 192.168.10.0. The hosts that are valid in that network are 192.168.10.1 to 10.6. And the broadcast ID would be 10.7. Okay, so those are the 8 IP addresses in that subnet, including the network ID and the broadcast ID. If I went to the next set, right, meaning I change the subnet portion of the ID to 00001, and then again we do our 8 choices with the host ID, you end up with a network ID of 192.168.10.8. The valid 6 hosts would be 10.9 through 10.14, and the broadcast ID is 10.15. And we could continue on and on through all the different subnets that are available. But if we just go back to our first one, right, the first range that we had, we know that the valid hosts are 1 through 6. So we need 3 of those, right, because we had a server, a client, and a router. We'll just take 192.168.10.1, .2, and .3. We know they can all talk to each other within this subnet. Throw that onto our simple network, and it's all fixed. The router is now 10.1, the server is 10.2, and the client is 10.3. Now, the last thing I'll tell you here is there is what's called the CIDR or CIDR notation. Without the notation, the way we saw it was an IP address of 192.168.10.1 and a subnet mask of 255.255.255.248. We can now simplify this by simply saying we have an IP address of 192.168.10.1 and put slash and then this 29, and that's the CIDR notation. The 29 represents the number of bits in the network ID. Okay, so if we go back a couple steps here, remember originally there were 24 bits in the network ID, right? Because we had 255.255.255. Those 3 octets, 3 times 8 is 24. But we've now added 5 more bits of the 32 to the network ID. So you add those 5 to the 24 and you get 29. And that's how you get to a nice simple notation of 192.168.10.1/29 representing that IP address.